So in this video, we're just going to be creating a ReactJS carousel. There's three types of navigation. We have next buttons and previous buttons. We can do a mouse wheel scroll like that, and it recenters itself. It snaps back like that. We have mobile, so we have touch. Let me just do an F5. It's perfectly responsive, so it maintains its width relative to the window width. If we go below a certain point, it just goes 100%. So we have touch navigation. We can do the buttons here as well. And so if this interests you at all, stick around. Let's begin. All right, so let's start with the touch navigation, and then we'll move on to the button and the wheel, and those should fall into place. So let's get mobile going first. So Control-Shift-J. Let's get mobile. What is this? Unique key prop. Let's handle that. Error. Just gonna add a key. Let's add the I. I like that. Let's save. Error's gone. Let's go mobile. Let me turn off the overflow so you can see all of the cards. Save. Go back. Good. Let's go mobile. Control-0. F5. All right. So let's partition off the code, and then we'll start programming. So this .set state, we'll do it right here. So the first guy we're doing is the touch navigation, like that. We'll do A5, CIW, fill in the stars, 2YY, touch navigation, button navigation, and then wheel navigation. So wheel right here, and this guy should be button. Clear off a star, okay, good. Space, space. Let me copy this and put it down there as well. We're just going to declare all of the add event listeners here. We're going to write the code for the body for the functions down here. So paste that here. Let's do this, format. All right, so touch navigation. We need some variables to keep track of where their finger is. So this .start touch position. It's when they first touch the screen. Where are they? We'll just initialize at 0. We need to know where to move the images. We'll keep that in updated position like that. We also want to modify the speed at which they're moving. You can do 1-to-1. You can play around with timing. Just when they scroll with their finger, we want the carousel to kind of lag behind. It just looks better. So we'll just do it in 80% like that. So a 20% decrease. And we need to keep track of where they are, where the images are on screen. Not where they are, but where the images. We'll keep track in an array called last positions. Let's fill out that array now. So let's do a simple loop. For let I is equal to 0. I is less than this .images .children .length I plus plus, and we'll just push some values into that the array. So this last positions. Let's see, last positions, and we'll do a push. We'll just do a parse float, and this .images .children of I, just their style.left property, style.left like that. Okay, let's declare all the listeners, not the skeleton, but we're going to declare the listeners here, and we'll write them down here. So 3 listeners. So this .touch area, .add event listener, we need the touch start, touch move, and touch end. So handle touch _start. And we need to turn off the passive. So passive equals to false, or we can't call the event.prevent default. I think this is Chrome's way of making the scrolling of the web page more efficient. I'm going to turn that off. So passive equal to false, like that. Paste. Paste. This guy's going to be the touch move. This guy's going to be the touch end. And let's do a 5x move, 5x end. All right, let's code these guys up down here. So handle touch start. We need the event object for this guy. Copy, paste, paste, space, space. This guy will be the move. We need the event object. And this guy will be the end. We do not need the event object for this guy. All right, so when they first touch the screen, we need to know where they touch. So this .start touch positions equal to event changed touches first finger. So first index or item of the array. And it's in the screen X property. And also, we need to zero out the transition durations for the images. So let me just copy this loop right here, because I don't want to write it. All right. Paste, format. And this will just be this .images.children There we go. Of I style transition duration. It's URATION and 0.0 seconds. All right, so that's good for the touch start. For the touch move, we need to know where they're moving to. So where's their finger currently? Before that, we'll do prevent default. So to get the current finger, we'll put that in a const. Current touch position, and that's just equal to the same thing. Event changed touches, the first touch, screen X. Now let's calculate the difference between the two, or get the difference. Just give me the current touch position minus this dot start touch position. And let's modify the speed at which the difference is calculated. So times equal that speed modifier. And let's update the touch start position. So start touch position is equal to current. Let me show you why. So save, let's open up my paint. Okay. Brush size, here we go. So start touch position, current touch position, difference. The next current touch position, start position, that's the difference. We already have this. We just want this as the difference. So that's why we need to update the start touch position. So start touch position, current touch position, difference. Start touch position, current touch position, difference. Start touch position, current difference. Start, current difference. We need to keep track of the start by updating it to the previous current. So close this, close this. That's this line right here. Start touch position, current touch position. So we have the difference. Let's move this guy. So let me move, or excuse me, copy this loop right here. All right, so where do we move it to? Updated position. Where are the images currently? Well, that's in the last positions array. So I plus the difference we just calculated. And let's finally move these images. So left is equal to the this.updated position. And it is a pixel denomination. And whenever we move the images, we need to keep track of where they are. And how do we do that? Well, that's the last positions array. Equals this.updated position. Save. And this guy's just used for the snapback animation. We're not doing that just yet, so this guy can just stay blank or empty. So save. Let's go back and see if it works. Do F5 for good luck. All right, good. So it's not exactly a carousel yet because they're not repeating themselves. We will handle that right now. And so we need to calculate a right boundary or threshold and a left boundary or threshold. When this card here crosses that right boundary, I'm going to take this card, put it in the front of the pack. Same thing with the left, crosses that left boundary, take this card, put it at the end of the pack. So we need to calculate a right boundary and a left boundary, and we're going to have a function handle that for us. So let me call that function before I forget. We'll call it handle boundaries, like that. Let me write the skeleton before I forget as well. Order cards, we'll do it right here. Handle boundaries, arrow function. All right, so what's the right boundary? Well, the right boundary is just where this card is, right here, where I have my cursor, plus one card width. So just keep in your mind's eye. Let's say this is the snapping point, or the right boundary right here. There's a line right here. When this card reaches that line somewhere there, that's when this card goes off screen, quote unquote off screen, and we need to snap or transport to the front of the pack. Same thing with the left. The left's boundary is where this card starts minus one card length. So when this guy hits that boundary, it goes off screen, and you want to take this card here and just put it on the end. So let's calculate the left boundary and the right boundary. We'll do the right boundary first. So this dot right boundary is equal to, and it's just where the last card is. So parse, we'll do parse float, this dot images, dot children, the last card, this dot state dot number of cards by index. And it's just its left value, style dot left plus one width of a card, which is just the new width. Left guy is just the same, reversed. So left, and it is the first card. So 1, 2, 3. Excuse me, not that. This could be 0 like that. And it'll be minus. So right boundary, last card, image children, style left plus, left boundary, first card, style left minus. All right. So let's handle the right boundary first. So if the last, wherever the last card is. So last positions, and it's going to be this.state.number of cards by index. If that guy is over the right boundary, this.right boundary, we want to calculate the beginning of the deck. So beginning of deck, where's the beginning of the deck? Well, that's where the first card is. So it's going to be, we can do this.last positions, the first one, minus this.new width. So at the beginning of the deck, let's move this card visually over to the front of the pack. And you'll see why I said visually to the front of the pack in a second. So let's just do what are we doing? This.images.children, and it's the last card. So this.state.number of cards by index, .style.left is equal to, and it's going to be beginning of deck, pixel value, there we go. And we move the card, so we need to update the last positions array as well. This.last positions of the same last position in the array, the last item in the array. So this.state.number of cards by index, and that's just going to be equal to the beginning of deck. So let's save and see if we got it to work. So that's the last card, this green flower. There we go. Now, notice this. Did I name these? I should have named them, right? The card they have keys. We'll see if those keys show up in the, let me do an F5, show up in the element here. You do this. And div root, we can't see it. It should be here. There. Images container. All right, what's unique to this guy that you guys can see here? In here, card. Let me give it an ID because you can't see the key right here. Give these guys IDs. Let's go here. It's going to ID equal to, let's say, we'll do this, card underscore I. Save, go back. See if you guys can see that then. Card, style. And we're not using it on the, we're not using it on the actual card. Put it right here. ID is equal to, we'll just go ID is equal to the props.myID. We'll send it as a prop here. So instead of ID, we'll do, what is it, my ID. Save, go back, and div my ID. There we go, card. Card 0, card 1, card 2. Pay attention to the order of these cards. Card 0, card 1, card 2. Can I increase the size of this just a bit? There we go. Card 0, card 1, card 2. On our screen, card 0, card 1, card 2. So pay attention to where the card 2 goes in the carousel visually, but more importantly, in the HTML. So here we go. There we go. So card 3, index 2, is now at the beginning of the pack visually. Where is it in the HTML? Well, it's still at the end of the pack. We need this card to go at the beginning of this list. And so this code here just changes stuff visually. It doesn't actually change the HTML, and it doesn't change the last positions array. Right here. This guy right here. So we need 2 more lines of code to actually change this guy from here to here. And because this guy went to the start of the pack, its last position needs to go to the start of the array as well. Let's start with the HTML. So this.images.insert before. We want to take the last card, so images children. That's going to be this.state.number of cards by index. And we want to put it in front of the first card, this.images.children 0. For our array, last positions, we're going to take the end, so at the beginning, so splice, first card, move 0. Which card do we want to put at the 0, 0 mark? We're going to put the last position, the last card. So it's just going to be this, the last positions. Just pop off the end card. There we go. Save. Let's go back here. Let's do an F5. All right, and pay attention to card 0, card 1, card 2. There we go. Card 2's up. Let me do this. Card 2's here, card 0, card 1. Popped. Card 1, 2, 0. Popped. Right there. 0, 1, 2. There we go. Let's just look at the first card here. Card 1, card 0, 2, 1, 0, 2, 1, 0. So let's just copy that logic, reverse it, and the left boundary should be done. So let's do this. No, I don't want this dot set state. I want that. I want if this dot last positions. So if the first card is less than or equal to the left boundary, it should be this dot left boundary. There we go. Then we'll just do all this stuff, just reverse the logic. Yank, paste, delete that. Let's calculate the end of the deck. That's going to be this dot state dot number of cards, and that's going to be a plus. That's going to be end of deck, and this is going to be end of deck as well. And we want to take the first card and move it to the end of the list. So instead of insert before, we'll do an append child. Which one do we want to append? We want to take the first card. So there we go, first card, and just move it behind the end of the last card. So that's going to be this dot state dot number of cards by index. And this guy is going to be a splice. We want to splice it at the end of the array. So it's just going to be this dot state dot number of cards by index. Move 0 over. And to take off the first element of an array, we don't use pop, we use shift. Let's save and see if we got this thing working. We don't really need this HTML anymore. All right, so there we go. The right obviously works. Let's go left. There we go. No, it didn't work. And it didn't work because we are not moving this one moves the last card. We want to move the first card to the end of the deck. So let's delete all these. And that's going to be a 0. And this is also going to be a 0. Save. Let's go back. Let's go right. That works. Let's go left. There we go. All right, so we're basically done the touch navigation. We just need to copy and paste that code into the button and the wheel, tweak it a bit, and then we're going to do the snapback animation. We do an F5. And we're going with buttons, which I can do on the mobile, so I'll keep on mobile. All right, so for the button navigation, we need one variable for this. This dot scroll in progress. You'll see why we need this in a second. I'm just set it to false for now. And the buttons, we're not going to declare them as separate things because we don't need to use event.prevent default. So we're just going to go the old or vanilla Java ReactJS way, which is just to do an on-click like this. This dot handle previous, and then we'll do an on-click as well here. On-click equals this dot handle. That's next, right? That is next. All right, let's code these guys up. Button navigation. We'll do next first. So handle next. We don't need the event object. Arrow function. You copy this, paste that here. And this guy is the previous. All right, so for the next, whatever, let's just copy the code. Let's copy all of this, including the handle boundaries. Whenever we move the card or move the carousel completely, we want to handle the boundaries. So paste that here. We don't need touch, so delete that. Difference, we can do a separate difference variable, but we don't need it. Delete that, delete that, delete that. So what is the difference, or how many pixels do we need to transport or translate the images? Well, when we click the next, we want another card, so one width of a whole card. So this difference just needs to be this dot underscore new width like that. Let's save. Let's go back, click next. Now notice let me do this. Turn on the hidden, save, go back. See what's wrong with that? See how instant? If you want that for your aesthetics, for your use case, that's cool. But let's build in a transition duration so we get that smooth slide. So right here, before we move the actual image, we'll just do this .images.children I style, that transition duration, and we'll just do 0.5 seconds. So 0.5 seconds, save, let's go back, let's go next, there we go. Now, if I do this, okay, so watch what happens when I spam the next button. See how I can do that? Let's prevent the user from doing that. That's why we need the scroll in progress. So currently the scroll in progress is set to false. What we're going to say is this: if there is a scroll in progress, you're not allowed to scroll again. If there's not a scroll in progress, we're going to set the scroll in progress to true. So there we go. So that'll prevent them from spamming the scroll in progress button. We'll allow them to scroll 1 card length. We'll handle the boundaries. And then once this animation is done, we'll turn the scroll in progress back to false. So that means they're allowed to scroll again. So that's 0.5 seconds. So we'll just set a timeout like this. Not like that. And we'll set this timeout for 500 milliseconds, which is 0.5 seconds, or half of a second. And this dot scroll in progress, set that back to false, like that. Save, go back, spam next. There we go. Can't spam it. So let's copy this logic, reverse it just a bit, and we'll have the previous button all done. And instead of going to the right, we'll go to the left. So we just need a minus here. Save, go back, spam next, good, spam previous, good, scroll, let's go next. Now notice how it's off its center. That's because we don't have the snapback animation coded yet. The snap would snap it like this, like that, just like, there we go. And it would just look perfect like that. All right, so let's finish the wheel navigation, and then we'll do the snapback functionality. So for a wheel navigation, what do we want to do here? We need a mouse over. So they're only going to be allowed to wheel when they're over the red area here. And since the wheel is desktop, let's go back to desktop here. Let's do F5. F5, there we go. All right, so what do we need? Right here. So this dot, we'll call it mouse over, set to false. And we're also going to need a timeout ID. Much the same logic as the scroll in progress, but it just calls the snapback animation. You'll see when we use it. This dot, we'll say wheel timeout ID, not mouse timeout ID. And we'll set that to null for now. And these listeners, we need to prevent the default behavior. So to code it just like this. So let me copy these 3 here. Paste, space, and touch area. So we're going to need mouse over. We're going to need the mouse leave. And we're going to need the actual wheel. And handle touch start, no. We'll do handle mouse over. We'll do handle, what is this one? Handle mouse leave. Handle mouse leave. And then finally, we'll just do handle wheel. Passive, 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 passive. Good. Let's code those guys down here. And that was handle mouse over. Do we need the event object? Mouse over? No, we don't. Not for this guy. Paste, paste, space. Not there. Space, space. This guy's going to be the handle mouse leave. And this is just the handle wheel. And we need the event object for this guy. All right, so when they first mouse over the red area, we want to tell our program that they're allowed to scroll. So this dot mouse over is equal to true. And just like we set the transition duration here to 0, I'm going to copy this code as well. 3 yank, and then we'll paste that down here. All right, so mouse over. When they leave, they're not allowed to scroll. So this dot mouse over is equal to false. On the wheel, first thing we do, prevent default behavior. We'll do the scrolling ourselves. And if they're allowed to scroll, if dot mouse over, then we'll scroll. So just copy the button logic. Copy, doesn't matter, copy this one here. Including the handle boundaries, but not the timeout, not just yet. So paste that here. And we don't need the transition duration. All right, so what is the, we'll do a plus here. So what's the difference here? How much are we moving by? We're just going to take the delta y of the wheel, so the vertical scroll of the wheel, that's kept in the delta y variable. Delta y, and we're going to slow that down by, or to 20%, or else it's just going way too fast, so 0.2 like that. And again, you could have, for all of these listeners, for the button, I guess you could have done it for the button, and the wheel, you could have absolutely done a different separate variable, calculated event.delta y, and just put the difference here. It's just a waste of coding, in my opinion. So there we go, event delta y, 0.2. Move the images, keep track of where they are, and always handle the boundaries. So let's save and see if we're good. Let's go back. Let's do an F5 for good luck. Let's scroll. There we go. Infinite scroll. Let's go the other way. Let's go next. Actually, we can't reposition with this. Let's go next. Previous. Let's go to the mobile. Control 0 just in case. There we go. And it's a bit wonky because we're not recalculating things. That's what I forgot. I'm glad I remember that before we went on to the snapback. Watch what happens here. So let's go within, let's go to F5 here. So, and I should do this with the overflow off. I'm glad I caught that. Save. Let's go back. All right. So infinite scrolling. Watch what happens when we resize this thing. So resize. Let's go Control 0 just to recenter it. Where's the infinite? Why is it screwing up like that? Well, when we resize, the boundaries change of this thing because the size, the widths of the images change. We need to calculate or recalculate those boundaries on the fly. So back up here. Where are we at here? Where did we do it? Boundaries right here. So we're going to recalculate the boundaries on the fly and obviously where the images are on the screen on the fly. So copy these and we'll just put it in the resize listener, which is right here, down here. So paste. There we go. And we're obviously not pushing new values into the last positions. We're just updating the positions that are there. So that's I like that. Equals parse float. Save. Let's go back. Okay, infinite scrolling. Let's increase the size to Control 0. Turn off the magnification and infinite scrolling like that. All right, let's go next. Next. Previous. All right, so all the navigation's done. We just need to code up the snapback logic. Before we do that, let me prep the code for those functions. So let's do, what should I do here? Where are the functions we're calling? Handle boundaries. We'll do it like this. Go snapback logic. Let's do this. Yank this, paste that here. Yank, paste. Let's call this guy the snapback logic. Snapback logic. And for now, I'm just going to say this dot snap in progress. Progress is equal to false. All right, so in order cards, that's good. Handle boundaries, handle touch start. So what we'll say here is if there is a snap in progress. So if the carousel is scrolling itself in order to reposition itself, we don't want to be able to interrupt that. You might want to do that in the future, but for this tutorial, we don't want to do that. So we're just going to return out of the function. Same thing for the move, like this. Event prevent default. There we go. And touch end. And let me just write this so I don't forget. We're going to have a function called snapback. And we'll define that down here. So let me copy this and paste that down. Handle mouse. We'll do it after the handle boundaries, which is right here. And it's going to be snap in progress. No, it's not going to be that. It's going to be the actual snap underscore back. There we go. So we call this dot snapback. Let me copy this line. Handle next. So if there's a scroll in progress, we'll just do an or here. Or there's a snap in progress. We don't want them to be able to interrupt the snap back action. So this dot snap in progress. Same thing for here. Or there's a snap in progress. That's good. Good. And we don't need to call the snapback animation for the handle next and handle previous because they're translating one whole card width over. So they're perfectly aligning themselves already. Wheel navigation, same thing. Just return. Same thing over here. So we'll just do that right there. And same thing over here. And let me code up the listener for this, or the the logic for the snapback. And so what that looks like is I did the wheel timeout ID, right? This dot wheel time, yes I did. So every time they roll their mouse over, we're going to call the snapback animation like this. Set timeout. And it's going to be this arrow function. We'll wait 100 milliseconds. This dot snapback. And so this dot wheel timeout ID is equal to. So every time they scroll their wheel, we call this function. If they scroll their wheel 1,000 times, 1,000,000 times, we call this function 1,000,000 times. This is not what we want. And so what we do up here is this. We'll do it right here just to be clear about it. Clear timeout of this dot wheel timeout ID. So every time they scroll their wheel, they set the snapback, but because the wheel still scrolls, on that next scroll, it clears that timer, so it cancels this function call. On the last scroll of the wheel, they set this timer, but because it's the last scroll of the wheel, it doesn't clear that timer. And so this function actually gets called. So just created a little mechanism by which we can understand when the wheel stops scrolling, call this snapback animation. So let me just double check before we get into that stuff, because that's pretty mathy. Order cards, we have handle boundaries, we have the snap in progress. We need some more variables for that when we started. We have the skeleton for this, which is good. Handle touch start, return good, return good, return good, or good, or good. We have the return. Okay, let's get into the snapback. It's a bit mathy. I'll be explaining it on my using my whiteboard. I'll be drawing a lot of things, so get ready for that. All right, so to get this snapback animation going, we need 3 new variables. So let's go down here, and let's add a distance to scroll. This is how the program's going to know how many pixels to go left or right, depending on some calculations below. So just going to initialize it at 0.0. We're also going to need a seed. This is for the animation loop. It's difficult to explain verbally, so you'll see when we use it. And we're going to need a snap speed modifier. This is how we're going to modify the speed at which our carousel snaps back to neutral. Just like it's going to be 0.5. It's going to be 0.05 when we finish with the timing functions. Just like we had a speed modifier for the touch navigation, we're just going to have a speed modifier for the snapback animation. All right, so that's good. Let's go down and start writing this function here. So first things first, we need to turn snap in progress to true, like that. And then I'm going to write some code, and then I'll explain it. It's going to be a bit hairy. So const adjusted positions is equal to, it's just going to be the last positions. We're going to map like that. We're going to take each position, and we're just going to return the absolute value of that position minus this dot new width divided by 2. And since we have that adjusted positions, let's calculate which card is closest to the snapping point. And the snapping point is relative to, or this closest card is relative to the snapping point. So closest card by index. And that's just going to be the adjusted positions. We'll do an index of, and we just want to return the minimum value. What's the lowest value in this adjusted positions array? So let's say, what am I doing here? Math.min, and we give it a bunch of values, adjusted positions. And now since we know the closest card by index, we need to know the actual value in that index of the array. So that's the distance to scroll. So this dot distance to scroll is equal to the adjusted positions, closest card by index, and we need to go left or right. So we multiply that by -1 or 1 depending on this. So this dot last positions, closest card by index, if that value is greater than this dot new width divided by 2, then we want to go left. So multiply it by -1. So -1.0, else just multiply it by a 1. Keep it the same value it is. And we have the distance to scroll, so let's call a separate function to do the actual animating, the animation loop. We'll call it this dot animate snap. There we go. Let's write that here. Animate snap, arrow function. And let's explain the snap back function. So what should they do here? So we have a problem. Let's say we have, let's do this. We have 3 cards on screen. This is the middle card, and everything's perfectly centered for now. So that's the last card, and this is the first card. Now the snapping point, you may think the snapping point is like right in the middle. It's not. The snapping point is right here. So whichever card is closest to the snapping point, we want that card's left border to be aligned with the snapping line or snapping point. Since this middle card, its left border is right on the snapping point, that's right here, we don't want the carousel to move. So it's already a neutral, perfect position. The problem we have is, let me show you the values and then we'll discuss further the problem. So I'm going to need, let's do, what should I do? When I click, we'll call the Snapback function because I'm going to show you guys some stuff afterwards. Console.log. I'm going to show you this dot, what am I going to show you? Last positions. And this dot new underscore width for now. Let's code a listener that calls that function every time I click. Let me just do it right here. Window, add event listener, click, and then we'll just do an arrow function, and we'll call this dot snapback like that. All right, save, go back, let's do an F5. All right, click, perfect. All right, so those are these values. Let me write those values. So what do we got? So this is the middle card right here, 175.5. The X value is right here, so that's 175.5. The guy on the right is 526.5, so 526.5. And the guy on the left is 175.5, but negative. 0.5, but negative. And the snapping point's X coordinate is, of course, the same as this guy because it's neutral. So this guy's also 175.5. Now, where do these numbers come from? Why 175.5? Well, this is the size of one width of a card. What is 351 divided by 2? 175. So why 175? Why this divided by 2? Well, if you remember from the first phase, because we transformed everything on screen using this right here, translate negative 50, 50, translate negative 50, we had to compensate for that when we ordered the cards. So if we go to the order cards function, this stuff right here, that's the 175.5, depending negative, positive, depending on which we're doing here. This is the negative, this is the positive, this is the positive. And so those initial values you would expect, because the middle card's in the middle and nothing's changed, nothing's moved, you'd expect that to maybe be like 0, and then one card over would be negative 351, and one card over on the right would be 351 positive. Because we made those transformations at negative 50, and we had to compensate for that in the, where are we at? We had to compensate for that in the order cards function. That's why these are the initial values, half, or this dot new width divided by 2. And so that leaves us with this. How do we get our program to understand that one of these cards, their borders, their left border specifically, is closest to the snapping point or snapping line? Well, we could do a bunch of math in order to get these numbers to be relative to 175. But what happens if we just ask our program a simple question? What's the lowest value given these 3 values? That's going to be the card or the left border that's closest to the snapping point. So if we ask our program that now, what's the answer? Well, it's negative 175.5. And so the program shifts all of our cards to the right, and this guy becomes the active card. This is not what we want. This is already perfectly aligned. We want our program to recognize that this guy right here, given these values, is the active card. So don't shift the cards left or right because we're already in a neutral position. It controls all of this stuff. And so how do we get a program to understand that this guy is closest to this guy given these values? Well, currently all of these values exist on a number line. So let's do this. Let's go green, orange, and then purple. So we have a number line like this. This is the snapping point. Snapping point is at 175.5, like this. This card right here, the middle active card, is at 175.5 as well. There you go. This card is right at 526.5, 562, 526.5, and this guy's at negative 175.5. And so this guy would be the negative 175.5. And so we ask our program, what's the lowest value? It says this one. It shifts everything to the right, not what we want. So let's make some transformations to this number line, and then we'll ask the program that same question throughout the transformations. And so currently you could say the zeroed out or the anchor the center point of the number line, is the snapping point, the 175.5. What happens if we wanted our number line to be centered at 0? How do we do that? Let's create a new number line like this. And that's the snapping point. What's 175.5 minus 175.5? Well, it's 0. And so we could transform the center of this number line, this new number line, to where the center point is 0. Well, since we subtracted 175.5 from the snapping point, the center of the number line, we have to subtract it from all of these values as well, basically shifting the number line or the values to the left. And so what is 175.5 minus 175.5? Well, 0. So this card's x becomes 0. What is 526.5 minus 175.5? Well, that's just half of 526.5. So this becomes 175.5. What is negative 175.5 minus 175.5? Well, it's 175.5 doubled, so it's 526.5, but negative. So 526.5. So we have a number line that's centered at 0. All the values are shifted to the left by 175.5. We ask our program what's the lowest value. It says this one, and it shifts all of the cards to the right. Not what we want. We want this guy to be the card closest to the snapping point. So what happens if we transform the number line one more time? Let's go purple with this one right here. So this is our new number line right here. We have our snapping point, which is at 0. What if we said, take the absolute values of every single number on the number line? And if you don't know what absolute values are, it's just the positive version of a number. What is the positive version of 0? Well, it's still 0. What's a positive version of positive 175.5? Well, it's still 175.5. Now, what is the positive version of negative 526.5? Well, that's positive 526.5. And so now we ask our program the same question. What's the lowest value given this array of values? It says, well, it's 0. And so it shifts the carousel 0 pixels in the left or right, doesn't really matter. And we have our neutral positioning of the images. So let's do all of these transformations one more time, but with values that are not quite so comfortable, so neat, because this is perfect, right? So we got 0, 0, 0 here. Let's say we shift all of the cards over 100. So we'll do the same color scheme, green, orange, and then purple. So green's right here. So the original last positions. So this guy is 175.5. But now we're shifting all of the cards over by 100. Nope, I want to go up. And these values here. So 175.5 plus 100 is 275. 526 plus 100 is 626. And that should be negative 75.5. Let's do that here. All right. So 175.5 plus 100 pixels is probably right here. So we get 275.5. And we have 526.5 plus 100 is 626.5. Let me do this. 626, 526, yeah, there we go. And negative 175 plus 100 is negative 75. So maybe somewhere right here. Negative 75.5. All right, so we ask our program, what's the lowest value? It says 75 right here. Shifts all of the images to the right. Not what we want. We want our program to understand that this is the value closest to the snapping point, and so shift all of the cards to the left. So let's make that first transformation of the number line, where the anchor point of the center of the number line is 0. So that's the new number line. 175.5 minus 175.5, 0. This guy goes down here. 275.5 minus 175.5, that's 100, like there. 626, let me see how I do that. 626.5, 626.5 minus 175.5, that's 451 for this guy. 451, and we get negative, can I do this? Negative 75.5, negative 75.5 minus 175.5, that's 251. So negative 251 like here. 251. We ask our program what's the lowest value. It says this one, shifts everything to the right. Not what we want. Let's make the final transformation of this number line, which is just to say, give me the absolute versions of all the numbers on the number line. There we go. Snapping point centered at 0. Absolute version of 100, still 100. Absolute version of 451, still 451. Absolute version of 251 negative, it's 251 positive, so I mean it's somewhere right here. And don't worry that this card, this number right here, is now in between these. So it's kind of out of order. We just care about the numbers. Visually, it won't be out of order. So we ask the question, what's the lowest number given these array of numbers? The program says this one right here, and it shifts all the values of the x values of the images to the left, and we get the aligned carousel. So let's shift all of those values. Let's do it one more time. All right, so the original number line was green, so let's use green. And let me shift just up a bit. Let's get some green. There we go. The original snapping point was 175.5. 175.5. And the original numbers were 100 shifted over. So this guy was 175, so this was 275.5. 0.5, let me just do this. This is 626. 26, right? Yeah, 626.5. And negative minus, that'd be plus 175.5 right here. 75.5 in the negative. Now we know we need to move 100 because of our calculations. We need to move 100 pixels in the left direction. We'll get to the direction after this. And so let's shift all of these values 100 in the left direction. What's 275.5 minus 100? Well, that goes right back here. 175.5. What is 626.5 minus 100? Well, it goes right back here. 526.5. What is negative 75.5 minus 100? Well, it goes right back here. That is negative 175.5. What are the values of our neutral array or neutral carousel? Negative 175.5, 175.5, 526.5. And so that's all these two numbers or two lines of code are doing right here. We're looping through the last positions and we're just returning the position minus the new width divided by 2. So that's the first transformation of our number line. Where we zero out the number line right here, and then we're returning the absolute value of those new calculations. That's the second transformation where we put all of the numbers to the right here, and then we're asking right here. Let me delete this here. Actually, we're probably going to need that. Let's do this. And then we're saying out of all of these numbers, these absolute values, which one's the lowest value, which is closest to the snapping point or snapping line? That's this line of code right here. Give me the minimum or the lowest value in that adjusted positions, in the absolute positions array. And so that gives us the value to move by. So in this case, it was the 100. So now that we have the number of pixels to move by, how do we know if it's left or right? Well, let's go here and let me give you this. Instead of last or new width, let me give you this. Let's give the adjusted positions. Let me save. Go back here. Let's do an F5. Let me Control L on the console. Let me blow up the console just a bit. Let me click. There we go. And so this right here is the adjusted positions. Everything's the absolute. And this guy is the last positions. We didn't touch the signage of the last positions array. And so if we just take the counterpart or the partner, where this guy is aligned with this guy's value is aligned or associated with this guy's value is associated with this guy. If we just take the signage in the original position, we're going to know if we go left or right. So that's just what this line is doing right here. So take those 100 pixels, and then based on the original position of the value in that array, in this array right here, if it's greater than this snapping point right here, if it's greater than, let's go all the way up here. So in the initial position, let's say it was 10 here or whatever, 100 right here. Actually, let's go back down then. Makes more sense. There we go. So given that we know to move 100 pixels, in the original array, this guy aligns with this guy right here. If this guy's value is greater than new width divided by 2, what's new width divided by 2? That's just the snapping point. So this guy's value right here is greater than the snapping point here, move it to the left. So just multiply by negative 1.0. Let's say the closest card was like right here. If this guy's value is less than the snapping point or snapping line, move everything to the right. So just multiply by 1.0. So that's all that code is saying. Take the 100 pixels, multiply it by its corresponding signage in the original array. If it's to the right of the snapping point, move it left, else just keep moving right. And we call the animate snap. So I hope you guys understood that. It's a bit, I don't know if it can be a bit confusing, but it could be a bit to bend your head around. But let's move on to the actual loop, the actual animation loop. So let me delete all this stuff here. Delete. Let's go up here. We'll delete this. Okay. So first things first, in this animation loop, we need to, so everything right now has a lot of decimal places to it. We just want to make sure everything's to 2 decimal places, just to keep things simple. So that seed we got right here. When we start, it starts at 0. I should put a semicolon there. It starts at 0, but it's going to be like 0.0005, 008, 8567, a lot of decimal places. I want to make sure that's just 2 decimal places. So this dot seed is equal to, we'll do a parse float, and we'll say this dot seed dot to fixed, and 2 decimal places like that. Now the next thing we need to do is we need to figure out how to get our program to go from one point to another. So we have a new problem here. Let me move to the right here. So let's say we have a starting position where the carousel ends up right. How should I do this? Let's do this. Starting position. We calculated the distance to scroll like that. And we want it to end up, let's do orange, at the neutral, or like perfectly aligned. We'll symbolize that with the square here. How do we get our program to go from the starting position all the way to the neutral or active aligned position? Well, what happens if we did this? Let's say we have the total distance to scroll here. And we have our seed. So that seed started at 0. What if we have a seed that goes from 0 all the way to 100? And we say, take that seed and divide it by 100. What would 0 over 100 be? 0 over 100 is equal to, that's 0%. What if the next turn of the loop we said 5? The seed's now equal to 5. What's 5 over 100? What's 5%? What if the next turn of the loop we have a 10 seed? What's 10 over 100? What's 10%? And what if by the end of it, our seed's equal to 100? What is 100 over 100? Well, it's equal to 100. So what if we take all of these, or this mathematical, call it like a mechanism or pattern, all of these stuff, right? All of this stuff right here, and we multiply this by the distance to scroll. Well, what is 0%? And say our distance to scroll is 100 pixels, 100 px, like that. What is 0% times 100 pixels? Let's just equal to, I'm just going to use one color for this. What's 0 pixels, right? What is 5% times 100 pixels? Well, that's 5 pixels. What is 10% times those 100 pixels? Well, that's 10 pixels. And finally, ... what is 100% of those 100 pixels? 100 pixels, like that. What's the full 100 pixels? So what happens if we took our program and we said start at a starting point, and this is the end point right here. First turn of the loop, give me 0% of the distance to scroll, so nothing. Next turn of the loop, give me 5% of the distance to scroll, and so it moves here. Next turn of the loop, give me 10% of the distance to scroll, and so it moves here. The next turn of the loop, what did I say? 510, 510. Let's just put like a 75 here. Give me 75% of the distance to scroll. Well, that's 75 is like right here. And the final turn of the loop, give me 100% of the distance to scroll. Like there, right there. So we're just going to create a mechanism by which we take the seed over 100. It gives us certain percentages. we multiply those percentages by the distance to scroll, and each turn of the loop, we're just taking more and more of the distance to scroll until we get to the final 100% of that distance to scroll. And you might think, well, we're adding this to this, this to this, this to this, this to this. So shouldn't this guy right here, let's say, shouldn't this guy right here add on to the previous? Well, that's not what the math is going to do. What we're saying every turn of the loop is always start from the start position and just add a certain percentage of the distance to scroll. Don't add this to this, which would give you like that. Don't add this to this, which would give you like something like that. So always start at the beginning. Give me 5%. Give me 10%. Give me 15%. Give me 50%. Give me 75%. Give me 80%. Give me 90%. Give me 100%. So let's go into the code and actually do that. So we're going to say let percentage to move, and that's going to be the seed divided by 100. Okay, and just like we just want 2 decimal places, we'll say percentage to move is going to be equal to a parse float of percentage to move to fixed to. Okay, so we have that mathematical mechanism, the 0 all the way to 100. Let's start moving this guy. It's the same way we've been moving it forever. So let's just copy this stuff here. Not including the handle boundaries. We'll do that later. I'll show you why. Copy this. Let's go back up here. Control V. Images children, not last positions. We don't need that right now. So what's the updated position? Well, wherever you are, plus this stuff. Your percentage times your distance to scroll. So plus percentage to move times this dot distance to scroll, like that. And we move the carousel here, and we have to make sure to loop this. So we're going to create a recursive function. So we're just going to say request animation, and we're just going to say this dot animate snap. And of course we have to increase the seed. So the seed starts at 0 and goes through one part of our loop. We need to increase the seed as we loop through. So we'll just say this dot seed is equal to, or plus equal to, 1 times that snap speed modifier. There we go. So let's save and we'll see if we get it. Save, go back, do an F5. All right, let me go. And we should expect this middle card here to scroll to the left. So all the images need to scroll to the left once I let go. So let me let go. And there we go. Now, why does it keep moving to the left? Well, we have a recursive function. Whenever you have a recursive function, you need some sort of logic that exits that recursive function. And so what's the exit logic for our recursive function? Well, when we have the total distance to scroll, that is to say when the seed is equal to 100%. So we'll go back into the code and we'll just do this. Now, if this dot seed is greater than 100, we know we're at 100%. First things first, let's turn off the snap in progress. So that's false. Second thing is second, let's neutralize the seed. So set it back to 0. And then let's finally make the final movement of the carousel. So the final movement of the carousel is the updated position is equal to wherever the carousel is plus the total distance to scroll. So we don't need percentages, we just need this. And since this is the final move of the carousel, we need to update the last positions array. Equals, and this dot updated position. And of course, whenever we finally move the carousel, we need to handle the boundaries. So this dot handle boundaries. And to exit out of this whole animation loop, we need to return out of it, like that. All right, so let's save, go back and see if this works. Let's do an F5. All right, so the middle card should go to, all the cards should go to the left, but the middle card should be centered. So let me let go. And there we go. Let me go to the left. Go right here, let go. And there we go. Let me do this. So it should be the, let's do the field on the left. Nope, that wasn't the closest one. Let's do that one more time. So it should be the, what are those ski things? Let's let go. There we go. Bam. All right, good. So notice how it's moving kind of, we describe this as, it's linear. It's modeled after a linear timing function. Every turn of this loop, it moves by 1 times, where are we at here? Right here, 1 times snap speed modifier. Snap speed modifier is 0.5. So the first turn of the loop, the seed 0, 0.5, 10, 15, 20, 25. So it's a linear progression. Every step is the same difference. Let's model this off a quadratic in order to get a different result. So let me show you guys what we're doing first. Let me go Control T, Desmos.com. It's an online graphing calculator. This is how we're going to model the timing function, or a function that we're going to use as a timing function. It's equal to x squared. Now, just like we had our seed here go from 0 to 100, which gives us 0% to 100%, what if we had our seed start at 0, but go to 1? What is 0 over 1? Well, it's 0%. What is 0.5 over 1? Well, it's 50%. So instead of going from 0 to 1, we can still go from 0 to 100. We can still go from 0 to 1 and still have these percentages. So watch this. Let me zoom up. Let's go a bit closer. Here we go. Look at the 0 to 1 range on this guy. That's 0, and then 1 is right there. That's 0, 1's right here. If we modeled our timing, or the way the seed was jumping from 1 to next, after this, what we get in terms of the feel or the visual, the look of the image carousel sliding. Well, we'd start very slow, like this, and then we pick up speed, and then we'd shoot up to 1. So instead of us having a linear progression like this, we'd start slow like this, where it'd probably be like this, 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 this. So you get a faster, a slow burn of sort of easing in, and then it shoot up like that. So let's reconfigure our carousel to use this guy as the timing function and not that linear mess. It just looks better. You can use a bunch of them. You can do something like this if you wanted to. Sine of x. Let's do 44. So this would be weird, right? Because your carousel would probably move right, left, right, left, right, left, right, left, right, left, right, left, and end up somewhere maybe in the middle, not even centered. But you could just use all of these functions here to model your timing. So let me close this. Let's go back to the code. And right here. So the snap speed modifier is too quick for a 0 to 1. This would happen in like 3 steps. 0, 0.5, and 1. So the animation would be way too janky. So let's lower that to 0.05 like this. Let's modify this is the timing function here. So instead of the linear timing function, we'll do the math.pow. So this dot seed to the power of 2, so a quadratic or second degree function. And the exit clause is not 100. When the seed is greater than 1, we know we're at the 100 mark. So let's save. Let's go back. F5 for good luck. Let's do this. Let go. There we go. Let go. Here we go. Let go. There we go. Let's do next. 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 Previous. 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 Let's go into desktop mode. Let's do F5. Let's do scrolling. 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 There we go. Next. Next. All right. So we're almost done. I was going to do this in a different video, but it'd probably take a quick 5 minutes. I didn't want to make a 5-minute video. Let's get these buttons to also be responsive on screen. So what are we going to do? I have some images we're going to use for the buttons. You can use whatever you want for your buttons. Did I put them in the folder yet? Should be, yeah, next and previous. So these are the buttons we're going to use. Close, close. Let's close this, and we need to go down to the HTML. So there's 2 parts to making responsive buttons. The size of the buttons need to be responsive, and the distance or the placement of the buttons also need to be responsive. So let's do this. Div dot, and we'll call this one buttons, call it nav buttons, underscore container. Like that. Yeah, it looks good. And we have 2 images for our buttons. So image, and these guys will have, let's say, nav underscore buttons, like that. And this will be the prev and next. And this will be ×2. Let's do this source. And this is guy, what did I name these guys? Just next and previous.png. Let's go prev for this guy, just to keep consistent. Okay, let's close this. This guy's the prev, so prev.png. This guy is ./next.png. PNG. The alt, previous, alt is next, class is okay, ID prev, ID next, and we need to have some references to these guys and the on clicks. So let me copy the on clicks instead of writing them out. Do control copy, paste it right here. Control V, the next, control copy, control V. ID is good. Let me comment these guys out. And we need references to all of these guys. Ref is equal to ref underscore ID. We'll call this one this dot nav buttons container is equal to ref underscore ID. We copy this, copy, and we'll do paste and paste here. This will be nav button underscore prev, nav button underscore next. And of course we need these styles. We have the class, we don't have the styles. They're right here. Style is going to be equal to what is it? Styles dot nav underscore button container, buttons container. And for this one, same thing, same styles. Styles dot, we say nav underscore buttons, like that. What's the class name on this? Nav underscore buttons. All right, let's write those styles here. The first one is nav underscore buttons container, and then nav underscore buttons. So nav underscore buttons underscore container, and this one is just nav buttons. Okay, just want to center these on screen, just like we've been doing for this whole thing. So let me copy all of this. Paste. Margin 0, padding 0, width. We're going to start at 100 viewer width. The height, we don't care. And positions absolute 50-50. We'll give this guy a blue color. So 0, red, green, blue. 255, we'll do 0.3 on this. Set index on top of the touch area. Okay, and we need to modify the, it's going to be a flex. So position, we'll do a display of flex. We'll do a flex direction explicitly of row. We'll do a, what is it, justify content. Might be content or items, we'll see. That's going to be space between. And I think that's good, we'll see. For the nav buttons, the width is just going to be 50%. So each button's going to take 50% of the width of the container. Actually, let me do this so you guys can see why it's 50%. So that's the width. The cursor is going to be a pointer. So when they move their cursor over the images, it's going to be a pointer. Cursor, pointer. Let's save and see if we broke the code. Okay, there we go. Let's go here, full screen. And so let's make these guys 50% each instead of 150. And I think I forgot one style. Content space between, the width, the height. We'll just do an auto. Save. All right, so let's make the size responsive and the where they are responsive. So their positioning. Let's start with the size first. So the nav buttons. So just up here when we do all the responsive code. Now we'll make the size of these buttons relative to the size of the viewport, which is to say one of these images, one of these cards. So right here, we're just going to say this dot what did we say? Nav underscore button. We'll do next and then previous. That's style.width is equal to some sort of value. We'll do that. And pixels, there we go. And it's just going to be relative to this new width, and new width divided by 2 because we're working within half. Each one of these buttons gets half of the flex box. Let's go GG up there. So this new width divided by 2, and this should be button previous. And we'll just do, let's see what looks good. We'll do 30% for now, 0.30. Let's do this. Save, see what we get. All right, so no matter where we go, it should be 30% of the width of half of this viewport. And it's not because it's initially good, but we didn't add that logic to the actual resize. So let's paste that here. Format, save. All right, there we go. So they stay the same size relative to the size of an image. Let me do this. Let me turn on the overflow. It's less visually confusing. All right, let me do F5 here. All right, so the size is taken care of. What about the position? The position's always 100% of the viewport. Well, let's do something here. So the position starts out at 100% of the viewport. We'll just create that same logic right here we did for the image width as a percentage. Let's do this. What should we say? Let's say nav button placement, buttons placement as percentage. We'll start off at, let's go 60% of the window. And we'll have the same clause here. So we'll say nav buttons percentage. If the window.inner width is less than 768, we'll take 100%, else we'll keep it at that 60%. So that'd be nav buttons percentage. We'll copy these two right here. We'll paste them right here. We do not need the let. And right, we'll do it after, before. We'll do before. So this dot, and it was nav buttons container dot style dot width, and this guy's in pixels, but we're having our nav buttons be in viewport width equal tildes, and it's just going to be nav buttons placement as percentage viewport width. Let's copy this line, place it in the resize listener. Let's see what we get. Save, go back. There we go. So no matter where we go, they're always going to be 60% of the width of the window, unless we go below 768. Can I do, it's lagging just a bit. Let's do this. Let's get rid of the whiteboard. Let's get rid of this. There we go, that's better. Notice we're below 768 right here, and the buttons pop to the right. Let me get rid of the colors. Let's go back down here. Background color, let's just comment it out in case you guys want it in your code when I upload this. There we go. And 60%. You can play around with the dimensions. This would look better if the image was 100% once we go below. So we'll also turn it on right here. Close. Or something, comment out, not close. There we go. Let's go back out. There we go. Let's go back. Can we close this or minimize that? Let's go back in. All right. Let's click, 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 click. Let's do some mouse wheel action. There we go. Let's do mobile action. We do F5 for good luck. Let's do this right here. Let's go a bit wider. Click, click. What am I doing? Let's drag, drag, drag. There we go. Let's keep dragging this way. Now I can't drag in the middle here because there's a div here. Let's turn off the what do you call them? Pointer events for the, we want these to be clickable, but not the actual container. So let's do this. What was that? The pointer events? Pointer events, none. Save, go back, F5 for good luck. So now I should be able to drag in here, perfect. So I'm only allowed to click on the, actually, it turned off for these guys, so we need to turn this on. Cursor, not cursor, excuse me. Pointer events, and we'll do an all here. Save, go back, F5, I can drag, I can click, there we go. Drag this, there we go. All right, so that's a long phase 2, but we have this thing fully functional. It's fully responsive, below 100%. We have touch navigation, there we go, like that. We have button navigation like that, and we have wheel navigation like that. So leave a like, it helps the channel grow. Subscribe if you haven't already subscribed. And I will see you guys in the next one. The next one, I don't know what it's going to be. I was thinking about doing more portfolio work. So ways of organizing your junior dev portfolio. Different ways like slideshows, image galleries, different types of image galleries, things like that. So look out for those. Again, like if you haven't already liked the video. Subscribe if you haven't already subscribed. And I will see you guys in those next ones.